Hello, good day. This is for the 2025 ninth IEEE Symposium on Wireless Technology and Applications. The study is entitled Evaluating Classification Models for Predicting Student Academic Outcomes. The authors are Joaquin Patino, Felicissimo Wenceslao Jr., and Patrick Di Serna. So, machine learning has become a vital tool for uncovering patterns and improving decision making across industries, including education. In academia, it enables institutions to predict these students who are at risk, learners, and the performance and the what are the targeted interventions based on the data for such as demographics and academic records. So this study evaluates different classification algorithms such as decision tree, random forest, support vector machine, k-nearest neighbor, logistic regression, and ensemble techniques to determine the most effective model for predicting student graduation likelihood. So by comparing these models' results, this research highlights the role of ML in enhancing educational planning, improving retention strategies, and supporting data-driven decision making. So the primary objective of this study was to evaluate the performance and classification models in predicting student academic outcomes, particularly graduation likelihoods. So this is to extract and pre-process students' data, including demographics and academics, identify and test the performance of various classification models using the dataset, and select the top performing classification model based on the evaluation metrics results. So the scope of the study, the data from undergraduate programs were extracted from University of Cebu main campus for academic years 2018 to 2019 until 2021 to 2022. It is probably not suited for students transferring from other schools or those with peculiar academic backgrounds. This is to prevent the biases if the population is less than 1,000 records. So the single institution nature of the study is a limitation as is the potential for biases inherent in reporting academic disadvantage based on socioeconomic status and the absence of long-term tracking of post-graduation outcomes. Therefore, uh, testing across institution may be necessary for generalizability across regions. So some sort of bias can be introduced, assuming class acts or transfer students will be underrepresented, and that limits the ability of the model. Therefore, adopters have to use fairness-aware machine learning techniques to monitor prediction bias in demographic data. There's also a certain quality that it will not only facilitate accurate predictions, but also parameters such as equity and fairness that are critical for creating inclusive and successful academic interventions. So these are beneficial. The study is beneficial to the following. So the incoming college freshmen or first year students with the vast range of options available to incoming freshmen and a minimal advice. This is where the tool comes in for to make recommendations. Guidance counselors for this model could suggest a good fit. However, counselors would also personalize the results and recommendations in terms of their circumstances. The deans and the chairpersons, which we call them as program heads, this attention to program and academic data allows them to evaluate the recommendations made by the model, feedback on how accurate or relevant they are about a program fit. So academic institutions, these institutions can invite incoming college freshmen who are most likely to succeed at that institution. So future researchers, these individuals may benefit from this study by expanding the model scope by adapting the system for different educational contexts and institutions. So the related studies, several studies have already been explored various machine learning models for prediction across in different fields. So classification is supervised machine learning technique categorizes data into discrete outcomes using models like ANN, random forest, decision tree, k-nearest neighbors, support vector machines, naive-Bayes, and logistic regression, as mentioned in the references of the study. Comparative analysis showed that tree-based and ensemble models RF and DT consistently outperform others in accuracy, F1 score, and AUC. In education, classification models have been widely used to detect at-risk students due to their interpretability and predictive strength. So studies combining RF with SVM and KNN improve graduation predictions, achieving accuracies above 95%. Overall, literature supports that random forest remains a dominant and reliable model in educational data mining, balancing interpretability, performance, and generalization. So for the methodology of this study followed the Knowledge Discovery Databases, KDD, which includes data processing, modeling, and evaluation. The dataset obtained from the ICT Center and Guidance Office contained 8,941 student records from 2019 to 2022. Feature demographic, socioeconomic, and academic indicators such as GPA, age, GPA, scholarship type, and entrance exam scores. Data preprocessing involve cleaning, handling missing values, encoding, and feature selection using tree-based models and the Gini index to identify key predictors. So for the methodology continuation, seven classification algorithms were evaluated using scikit-learn in Python, namely AdaBoost, Decision Tree, Logistic Regression, Support Vector Machine, Naive-Bayes, Random Forest, and Extra Trees. Data were split into 70% for training and 30% for testing as the datasets, with performance measured through accuracy, precision, recall, F1 score, and AUC. Model optimization used randomized search CV for hyperparameter tuning, improving generalization through random sampling of parameter combinations. The random forest classifier achieved the most stable and accurate performance, confirming its suitability for predicting student graduation outcomes. For the results and discussion of the study, the seven classification models were compared to predict student graduation outcomes. Among them, the random forest classifier achieved the highest accuracy of 87.82%, precision of 0.90, recall of 0.89, and AUC of 0.9643. After hyperparameter tuning, using randomized search CV and tenfold cross-validation, the model's accuracy improved to 90% with balanced metrics with a precision of 0.9016 and a recall of 8.8998, an F1 score of 90.02, and an EOC of 0.9657. For the results and discussions continuation, other models such as AWS 86.42%, Extra Trees 84.61%, and Decision Tree 84.49% performed well but showed less stability. Logistic regressions, support vector machines, and naive-Bayes produced lower results, indicating that it limited handling of complex relationships. Overall, random forest proved most effective for academic outcome prediction, balancing robustness, interpretability, and accuracy. Feature importance analysis further revealed that GPA, entrance exam score, and socioeconomic factors were key predictors, providing actionable insights for student retention and academic advising. For the conclusion and future works of this study compared several machine learning models for predicting student outcomes. Among them, the random forest classifier achieved the highest accuracy of approximately 90% after it has been fine-tuned. And then feature importance analysis revealed that age, academic support, scholarship status, language, GPA, and SHS GPA significantly influence student success. The proposed hybrid approach, which can be integrated later on as a future work, integrating classification and regression models prove more accurate if ever this will be continued for future works. And then addressing also the gaps in the local Philippine research. And then for future work, the model can be deployed in academic advising systems, expanded to other institutions, and enhanced with real-time student data to improve prediction accuracy and decision support. Thank you very much. Thank you very much and have a good day.